Welcome to today's Explainer. We're looking at a topic that honestly sounds like pure science fiction, yet it is entirely, undeniably real. Okay, let's dive into this. I want you to picture discovering a rock, just one single rock, floating silently through the massive void of space. But wait, this isn't just your average space debris. The resources locked inside this single celestial body are literally worth more money than the entire global economy combined. So today, we're exploring the celestial gold rush, and we're going to look at how mining the final frontier is rapidly shifting from a distant sci-fi dream into a very real, present-day race.
Look at the number on your screen. That is 1 quadrillion. Take a second to really just let the staggering, almost alien scale of that number sink in. When we talk about the wealth drifting silently through space, we are not talking about millions. We aren't even talking about billions. We are talking about quadrillions of dollars in potential value. It's a scale of wealth that honestly defies human comprehension, just drifting out there in the dark.
So what exactly makes these asteroids so unimaginably valuable? Well, we're talking about deep space treasures here. Gold, platinum, nickel, and a massive abundance of rare metals. To put that into perspective for a second, a single metallic asteroid could easily contain more platinum than humanity has mined in the entire history of Earth. And these are the exact same materials that are becoming incredibly rare and super difficult to extract down here at home. So the real question we're facing right now isn't if we'll find them, because we already know they're out there. The real question is, who is going to own them first?
Let's move to and see how this builds. Section 1, Mapping the Asteroid Belt. To ground us in the celestial geography a bit, the primary hunting ground for all this is located roughly halfway between Mars and Jupiter. Out there, in the main asteroid belt, you've got millions of ancient rocks that have been drifting in this silent cosmic dance since the literal birth of our solar system. And hey, contrary to what you see in the sci-fi movies, they are not clustered together in some dense, chaotic minefield where you have to dodge and weave. They're actually incredibly far apart, which makes mapping them a massive logistical hurdle. It's essentially a giant debris field of history, holding the raw, leftover ingredients of planets that just never quite formed.
Now keep in mind, the vast majority of these millions of rocks are completely ordinary, but a select few are absolutely extraordinary. Their potential is literally paradigm-shifting. The resources locked inside just one of these prime asteroids could power human industries for generations. We're talking about fundamentally changing the cost of the technology you use every single day. And this is exactly why, for the first time in human history, our search for ultimate treasure is shifting away from the dirt beneath our feet, and we're looking up toward the stars.
Section 2, Deep Space Mining Technologies.
So the crucial point is the specific toolkit required to actually pull this off. Right now, all across the globe, scientists and engineers are actively developing 4 core technologies for these deep space mining missions. First up, we need powerful rockets, specifically reusable heavy-lift vehicles that completely slash the cost per launch. Second, autonomous mining robots. We're not sending astronauts with pickaxes up there, right? We're developing wild tech like optical mining, where concentrated sunlight actually fractures the rock to extract water and metals in zero gravity. Third is artificial intelligence. Because a communication delay is of up to 40 minutes, we absolutely need autonomous AI swarms that can navigate, operate, and adapt in real time without us holding their hands. And finally, number 4, return spacecraft. These have to be capable of surviving intense thermal reentry while carrying tons and tons of dense, heavy payload. These 4 technological pillars are the absolute foundation of this new space race.
But mastering all that tech comes with a massive barrier to entry. Every single kilogram launched into space costs money. The sheer financial burden required just to achieve escape velocity with all that heavy, highly specialized mining equipment, it's astronomical. We are talking about needing massive upfront capital before a single ounce of space gold is ever brought home.
And this brilliantly illustrates the ultimate cosmic gamble we're looking at here. On one side, you have enormous risk. A single software glitch in the harsh vacuum of space means billions of dollars literally vaporize in an instant, long before the first piece of metal is ever collected. But on the flip side, unprecedented reward. A successful mission wouldn't just turn a nice profit, it would entirely redefine civilization's wealth. It's a risk-to-reward ratio unlike anything humanity has ever encountered.
Section 3, Economics of Unlimited Wealth.
Let's think about the basic laws of supply and demand for a second. If a private company suddenly brings back millions of tons of gold or platinum, what actually happens? Would these incredibly precious metals suddenly become common? Would they just completely lose their value overnight? I mean, if you flood the market with this unlimited celestial supply, the very foundations of our global financial markets could be thrown into absolute chaos.
And, those economic questions very quickly morph into intense geopolitical ones. If one company or even one country controls the richest asteroid ever discovered, how does the rest of the world react? Would this new abundance usher in a golden era of global prosperity, or would it trigger a fierce, tense conflict over off-world monopolies? Faced with infinite abundance, would humanity finally choose to share? The political fallout of a successful mission is honestly just as unpredictable as the economics. Now, what's really interesting about this slide is that we are looking at a scenario that could very well elevate today's billionaires into the world's very first trillionaires. The source material makes it crystal clear. The first successful asteroid mining mission won't just advance science, it will completely redefine global economics and existing power structures. We are simply observing the reality that whoever taps this new frontier first is going to hold a concentration of wealth previously thought to be impossible.
Section 4. The next gold rush.
For centuries, human beings crossed dangerous, unpredictable oceans in search of treasure and new frontiers. That was the edge of our map. But the future? It is entirely different. The next generation isn't looking across the water anymore. They are preparing to cross the freezing, expansive darkness of deep space. The greatest gold rush in human history isn't going to happen underground. It's going to happen up there, among the stars. We're literally watching a generation reach farther than anyone ever has before.
I want to leave you with this final, powerful thought from our source material. The greatest treasure in human history is still waiting to be claimed. Somewhere out there, drifting silently in the dark right now, is an unimaginable fortune. The future belongs to those willing to reach for it, and the countdown to that future has already begun. Thank you so much for joining me for this explainer. Keep looking up, and I'll catch you next time.